And then the principle of least privilege, which means you should always give users and systems with access to only what they need to perform their day-to-day jobs. Like this means that if a user doesn't need administrative rights access, the user should never be allowed admin rights on a PC or on a system. And in general, ideally speaking, in most organizations, even the users that have admin rights, they don't use those accounts on a daily basis to work. Like what I'm trying to say, if I'm Christian and I have a domain account admin available, I'm not going to log into my computer with that domain account. What I'm going to do, I'm going to use that domain account only when needed. Like I'm going to use those credentials to join a computer to a domain. Or I'm going to use those credentials to log in to a domain controller so I can do any kind of changes, any kind of security policy changes, for example. But I'm not going to use that domain account to log in to my computer, because at that point I'm putting at risk the whole network. Because when I'm using a domain account on a computer, first of all, I want to be granted full access on the local computer, which means that whatever I do in the user environment is going to be able to change everything on a system. And at the same time, as a domain admin, I have pretty much a lot of, not unlimited, but I have much more access to network resources as opposed to a regular user account. So which means that if I have local admin rights and my system can get compromised, then the attacker can make use of the same credentials that I have in order to get access to more network resources, which could possibly mean confidential data in there. So the least privilege means, as I was saying, give users only access to what they need to perform. And also the users that they have more privileges, like if we speak about operating system privileges, they should not use those accounts. They should use those accounts only as needed. And then network access means that at the network level, you need to implement technologies so that each connected endpoint, if it's a printer, an IP camera, a user, and which type of user, which type of endpoint, is granted access to the network only as required, not full access to the network. Likewise, we can speak about what's called separation of duties, which what that means is that a user does not have a privilege level 15 on a device, and also to the command auditing system. So separation of duties should make sure that if a user does a bad thing in the network, like if a user deletes a file, or if a user copies a file to leak it out of the network, or if a user erases a device configuration, that user does not have access to the systems where his actions were logged. So the user can delete the logs, so it can basically hide its traces. So when a user does something, so the user is privileged enough to take a specific action, that user should not be privileged enough to also hide what he's been doing, because at that point that's a big problem. Okay, because in the case of an incident happening, the worst thing you need is not being able to look at the log system or look at the auditing system and identify which user has done what. Okay, and that's not for the scope of mainly prosecuting or getting the user to court for judgment, but to see exactly what happened. Because if the logs are being deleted, then you don't even have an idea of which data was leaked, what had happened. That's the most important aspect, that you lost visibility into what happened in the network, not that you lost visibility into who did what exactly. But both of them are, of course, important. And as I was saying before, your network is as secure as the weakest link. That's another common design principle. And in general, humans are considered to be the weakest link because they can be easily manipulated. And by using other principles, the risk can be lowered. So what I'm trying to say in here is that as we have protocol flaws, software flaws, system design flaws, we also have human flaws. But for a computer flaw or for a protocol flaw or for a network design flaw, we have, those are technical flaws, we have technical countermeasures in place. It's only a choice of us if we want to deploy those measures or not, depending of course on a risk analysis of the assets and vulnerabilities and threats. But then with the human flaws, this is not something that you can easily provide countermeasures for. Like for example, it's easy to somebody calling like I'm gonna call somebody from Google, or from whatever company, behaving like I'm the guy from the security department, and asking for their user credentials because we have to identify a specific problem in their system. I'm going to call someone and say, hey, I need to connect to your system because it seems that something is wrong. What is your password? Then the user tells his password over the phone, and then the attacker says, oh, can you also confirm your username out of security reasons? And then the user says, oh, sure, my username is whatever the username is. And at that point, the attacker got access to the user credentials, and then basically he can do whatever that user can do in the network. So this is more difficult to let's say to provide countermeasures for. But as I was saying, by using other principles, we can lower down this risk. Like we're going to see, we're going to give examples when we go to specific kind of attacks. Like for example, if you let me give example of the weakest link with other principles. Like for example, weak passwords, right? So users in general pick up weak passwords. So how can we? That's again a human flaw, which makes the security chain weak in the end. Because if the user's passwords is unsecure, it's easily broken. Then somebody can identify the password, log into the systems in the names of the users, and get the same access as the user have in the network. So what we can do is we can force the users to put in complex passwords by creating a correct security policy. So that's what I'm trying to say by saying to the use of other principles, we can lower the risk in here, because you can actually force the users not to be allowed to put in their weak passwords to begin with. You also have what is called accountability and non-repudiation, which means that all user activities should be accounted and audited for, which is useful for forensics analysis. Like for example, if I am Christian, I'm a network admin, and I have logged into a specific device, and because I was mad on my company, I have deleted the configuration file of a firewall where I have allowed full IP and any traffic from the internet, then that has to be accounted for so that everybody is aware of what have I done, so they know how to fix that up to begin with, and also the organization is aware of who has done that, so they can of course charge me and take me in court for prosecution. And the gathered data, so the auditing system and the accounted and audited data has to offer evidence as not being tampered with. So as I was saying, if I ended up on purpose erasing the configuration of a specific device, and that was logged via TACACS accounting, then the employer, the solution, the TACACS solution has to have built-in, let's say, characteristics to provide evidence that the logs had not been tampered with. Because the user might say, I have not done that. Somebody else has placed those logs in the TACACS system. The user can bring this as a defense in the prosecution, when he's being prosecuted. The user can say, I have not done that. Please provide evidence that I am the one who has done that. So then the company has to make sure that the getter data can is basically offers non-repudiation, so the user cannot negate what he has done to begin with, because otherwise the data, the log system has zero value if we cannot prove that log message showed up as a result of the user taking a specific action on a system.